Now, you're welcome.
Are you blonde?
Look over! This is 1 through 8. Everybody good on 1 through 8? Crap, I cannot get my crap together. All right, turning points. Turning points on a graph. And actually, let me do.
That's actually not how it is.
What? The guy didn't know? I know, but I want it a little bit different because I'm gonna go a little bit deeper than what the notes go. All right, the first thing I want to talk about, turning points are places where the graph changes direction. Now, what do I mean by changing direction? As I move left to right, you read a graph the same way you read a book, right? Left to right. As I start here, I am either going to be increasing or decreasing. Increasing goes up, decreasing goes down, right? So as I start out here and I'm moving this way because this is left to right, am I increasing or decreasing? Increasing. Does everybody see that? Do you get it? The point where I stop increasing and I start decreasing is what we call a turning point. Because my direction changes. I stop increasing and I start decreasing, okay? Now, in the past, we've called this a vertex if it's on a parabola, or we might, maximum and minimum, that's exactly right. It's not, I'm laughing at Finley making his bagel over there. All right. So, okay, so if the turning point, let me finish labeling this graph and then we'll talk about those. All right, so I'm decreasing, 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 and then at this point I stop decreasing and I start what? Increasing. And then I increase until I get to this point, and then what am I doing? Decreasing. Okay, so I wanted you to see why they're called turning points. And the reason I used a different graph than they did is I'm going to show you in just a second. This one, if this is a maximum, what is this one? A minimum. And this one up here, a maximum. Now, we have different kinds of maximums and minimums. Okay, boys. This is what we call a relative maximum because it's a maximum, but there are other points higher than that on the graph. So even though it's a maximum, it's not the highest point on the graph. However, did you see that this point is the highest point on the graph? There's never a point that ever goes higher than that, right? We call that an absolute max. So I want you to see the difference in a relative. Sometimes it's called a relative or a local maximum as opposed to an absolute maximum. And the same holds true with minimums. So would this minimum be a relative or an absolute? Why is it relative? That's right. Look, these go down forever, right? So this would be relative. Okay? Everybody okay on relative as opposed to absolute? No, this is not in your. Okay. I haven't got to that yet. All right. What? Yeah, it's a high point. It's a turning point, but it's not the highest point on the graph. Yeah, the second highest. Now, we should have done this. This was supposed to be, there was on your last test, there were some places that said increasing, decreasing, and I told you just mark those out. We'd get to them because I'd rather hit them here than I would there. So you might want to write this on the side somewhere or something like that. But we can define our intervals of increasing and decreasing based on these turning points, okay? So let me just give it some random values. Let's say this was 2, 5. Let's say this was, let's see, 3, -1. And let's say that this point is 7, 7. Let's make it 7, 8. All right. I can describe these intervals using interval notation. So if I was asked for the increasing intervals, that means where all is my function increasing? And I've already got them labeled, so it'll be a little bit easier. Negative infinity, because it's forever to the left, until I hit this point. That's my increasing, right? What is that point? I'm using x's to describe. 2. I do a parenthesis, and then I go, but wait, that's not the only increasing interval, because it also increases from here to here, right? So I would do a U, and I would go from 3 to 7. Because at that point, it's neither increasing nor decreasing. It's at a, yeah, it's turning right there. Well, the positive infinity is going to be part of my decreasing interval. So it's decreasing, what are the intervals on which it's decreasing? From 2 to 3, I'm looking at the x's, right? From 2 to 3, that's decreasing. And then from 7 to infinity. It's always changing at turning points. Just a third. Okay, we'll keep practicing with that, but I wanted to point that out. So now let's look at your notes. If the turning point is higher than any nearby point, any nearby, it's a relative maximum. Yeah, it will. Yeah, it will.
No, it won't.
You have to use the caret above the division sign.
I did.
Maybe. Oh, yeah.
We need this table is trash.
Okay. If the turning point is lower than any nearby point, relative minimum. Maximum and minimum values are called what? Bless you. Turning points. It's in bold to the left. Turning points. Turning points. Turning points define where the function is increasing or decreasing. Okay, now, here's what we're going to do. By the way, every max or min is a relative, but every absolute is not. I mean, every relative is not an absolute, but every absolute is a relative. Does that make sense? Like, yes, this is an absolute max, but I could also call it, by definition, it's still a relative max. Do you understand? It's still the highest point in a certain area, but it's also, it's kind of like every square is a rectangle, but every rectangle is not a square. Same kind of thing, right? All right. I just say that because if you look, all of your things on here are asking for relative max and relative min. You're giving all the maxes and mins, even the absolutes there, because they're also. Okay. Here comes the fun part. Sweet baby Jesus, help me explain this well. All right. And help Bella understand this well. All right. Dot cam. Yes, get out your calculator. Your calculator. Finley, stop saying stuff like that. Oh.
Mom don't let me eat any food. Yeah, cardboard box that rained on last night. My cardboard box that rained on. My pit broke with the wind yesterday.
I want you to be able to see everything, but I kind of want it to be. All right.
I was one of those people who were killing pets immediately.
All right, here we go. Shut up, Grayson.
I didn't have enough food.
Let's practice first putting this in as an equation, and we have done this before, and we have found the zeros, yes? Didn't we do that in here? All right. Looks kind of blurry. All right, go to y equals. I'm going to clear this out. Also, make sure up at the top, you see where it says plot 1, plot 2, plot 3? Make sure none of them are highlighted like that. If they are, just go up, click on them, hit enter, and come back down. So your screen should look like my screen. Everybody with me? All right, we're going to do this one that's an example on here first, this x cubed minus 6x squared plus 7x plus 2. So let's put it in. So Matthew says that he can't put a cubed in his, so let's see what's going on. X right here in this box here. X, I have to do this little caret above the division sign, to the third Now, if you've got a fancy calculator, you may have to hit the arrow to the right to come down off the exponent. Minus 6x, and then I always use this one for the squared button. You could do the little caret again and do to the second power. It doesn't matter. Plus 7x plus 2. Everybody with me? All right, this should be what kind of graph? What's this called, by the way? A cubic. A cubic. How do I know it's a cubic? The third power. Cubic. Well, there's 4 terms, so it's a cubic polynomial, right? What should my end behavior look like on this? The right side should go which way? Up. And the left side should go down. Just like a line with a positive slope. Okay? Is negative, right? All right, I'm going to hit zoom 6. I always start out with a zoom 6. That's a 10 by 10 window. That's usually the easiest. Standard. Yep. Now, I've got a beautiful cubic graph here, right? It's got a max. It's got a min. Are they relative or absolute? Relative, and they are not absolute, right? Because the graph goes up forever and down forever. In fact, any odd function is never going to have any absolutes because the ends go off in opposite directions. Absolute is absolutely the highest point on a graph or absolutely the lowest point on a graph. It only even functions have absolutes. Yep. All right. Let's start with the maximum here, okay? Yep. So hit second, never just do trace. Hit second trace beside the graph button. And look, I have the option for 0, minimum, and maximum. Those 3 we're going to use a lot, okay? I'm going to choose maximum, which is number 4. You can either hit 4 or you can scroll down to it. Okay, here comes the fun part. My spider, remember my spider. Okay, it's telling me left bound. That is saying I need to go to the left side of the maximum, okay? So if the maximum is somewhere around here, I don't know exactly, I need to make sure that I click left enough times that I'm past the maximum, okay? I usually say 3 times a good time to be past it, but you see how clearly I'm to the left of the maximum. Do you agree? Hit enter. Once you're to the left of the maximum, hit enter. I might go left another click and hit enter. And now it says right bound. Same thing. I need to make sure that I am to the right of the maximum. So put it somewhere close to the maximum and then make sure you go right enough to where you're past it. So if I'm right here, am I on the right side of the maximum? Yes, definitely I am. So I'm going to hit enter. And then it says, hey, do you want me to guess? Well, that's why I chose maximum. That's what I'm doing. So I hit enter one more time. And here are the coordinates. Take them out 3 decimal places. Okay, 3 decimal places at a minimum. So here's what we say. And I'm going to start teaching y'all this notation now because calculus still has issues with this. So maybe if I start drilling it now, everybody will understand. The maximum occurs at the point 0.709, 4.303. Remember, I need 3 places. So this is my relative max. Now, what I say is I have a max value of 4.303 at 0.709. Anytime I describe where, that's my x. Anytime I say function value, that's my y. Okay? You try calculating the minimum here. Yeah. Yep. Those this is all you need to put on relative max part. Parentheses. Always, if it's a point, it's just a point. All right, now go to your calculator and find the minimum. Huh? Second trace. All right. If you're having trouble, let me go with you. Second trace, minimum. I always go to that point and then it says left bound. So once I get close to where it is, that's whenever I go, okay, I'm going to make sure I click left enough to be past it. And hit. Go to where the minimum is and then go to the left of that. Hit enter and then right bound. And then, so then I want to be on the right side. Make sure on your calculator you can get the exact point that I got because that's what I'm going to be looking for. I'm looking for your 3 decimal places that are correct. So 3.291. Did you hit enter one more time? And negative 4.303. That point. Or, here, I'll put the calculator up. There it is. Yes. I don't know why students struggle with this, but they do. No, it's not shade. Oh, that's the same thing I got. What's the 0? 3.2. I rounded. That was my phone. All right. That would be terrible. That would be a minimum. What do you mean for what?
Like if you're gonna determine if it's maximum, like the point to the right or left.
If it goes from decreasing to increasing, it's a minimum. If it goes from increasing to decreasing, it's a max. Minimum. All right. What? But let me just show you how we would sketch it and then what we're going to do. So if I were sketching, you do not have to be exact about your sketch, okay? Not at all. But it needs to resemble what's on there. Like I would do this for the sketch of this particular graph, okay? And then they ask you several analysis questions over to the right. First thing they're going to ask is, what's the domain? That's when you tell me what the domain is. Negative infinity to infinity. What's the range? Negative infinity. Every odd function, if it is an odd degree, the domain and range are going to be negative infinity to infinity. Then it's going to, the range is going to be restricted depending on if it opens up or down. Okay, yep. So if I am doing this, what I would do is I would label these relative maxes and mins. What was this? The max was 0.709, 4.303, and then this one was 3.291, negative 4.303. Okay. The next thing says relative maxes and mins. I've already told you what those are, right? So then I go to in behavior. We've already talked about in behavior, but let's just do it one more time so you know what you're looking for. As x approaches infinity, f of x approaches what? Infinity, because the right side goes up. How about the left side? As x approaches negative infinity goes down. Okay. So then, what are the intervals? And I think y'all are asking me that because that's listed right here. All right, so increasing intervals. I also find it easier to label my graph because it makes it easier for me to see. I know this is where it's cutting off. This is increasing. This is decreasing. This is increasing. So now all I have to do is name these intervals. And I will usually do it together. And I will start at the far left. How does it start out? From negative infinity, it starts out doing what? Increasing. Here's increasing. So negative infinity starts out increasing until I get to what? 0.709. And then from 0.709, it starts doing what? Decreasing. So I'm going to jump down here, 0.709, until what? 3.291. Then what does it do? Increase. Oh, I got to add another part to my increasing. So I do that with a U from 3.291 to infinity. So there's your interval. Does that make sense to everybody? You don't know? I'm just using these points to do it. Your calculator what?